Okay, welcome back everyone. So in this video we're going to look at an example problem of using Newton's law of universal gravitation, and in this particular problem this is going to be number 82 in chapter 7, and we're going to be looking at, by the way, that's on page 253. We're going to be looking at when gravitational forces are equal. So for example, here we have the Earth and here we have the Moon, and there's got to be some point in between them where the gravitational force of the Earth on an object, we'll call it little m, is the same as the gravitational force of the Moon on that little m. And so our job is to try to find that point. And again, we're going to do center to center distance. So we could call this distance x, and then we would need to call this distance a second variable, except we know the total distance from the Earth to the Moon is 3.84 times 10 to the 8th meters. So that means that this is 3.84 times 10 to the 8th minus x. If I add these two together, I should get my total. Okay, so this allows me to set up an equation. The force of gravity between the Earth and little m is equal to the force of gravity between the Moon and little m. And so I apply Newton's law of universal gravitation, G m for mass of Earth times little m over x squared is the distance from the Earth to the object. That must be equal to g times the mass of the Moon times the mass of the object divided by 3.84 times 10 to the 8th minus x, quantity squared. And so now a couple of neat things are going to happen. First of all, the constant will cancel out, and that's nice. I don't have to worry about that. And the mass of the object itself will cancel out. And so we have a fairly simple relationship here, and we have the mass of the Earth over x squared is equal to the mass of the Moon over 3.84 times 10 to the 8th minus x, quantity squared. Well, let's get rid of those squares. Let's just take the square root of everything. So that means that I get the square root of the mass of the Earth over x is equal to the square root of the mass of the Moon over 3.84 times 10 to the 8th minus x. Okay, now the rest of this is just algebra. We plug in the fact that the mass of the Earth is about 6 times 10 to the 24th kilograms, give or take, and the mass of the Moon is about 7.4 times 10 to the 22nd kilograms, and we just solve the resulting equation for x, and what we get is that x is about 3.4 times 10 to the 8th meters. And so what we've done is found out the point between the Earth and the Moon where the gravitational forces are equal. So then the follow-up question is, are these the only forces? And if we put something at that point, if we put a satellite here, would it stay put? Would it truly have zero net force? And the answer is no, because, well, let's not forget, we still have the sun. So if we zoom out, so maybe the sun is over here, and the sun is going to exert a pretty big force on everything. So let's not forget about that. Okay, so the main point of this exercise was to show you how to set up Newton's law of universal gravity, and we'll have lots of practice with this in the future.